Now this is the example. Let us say that fx is a periodic function and the one period is defined by this formula, this expression. This is piecewise linear. We are dealing with periodic function, piecewise linear, and then we are going to integrate it what the Fourier series says. So Fourier analysis, Fourier transform, the Fourier series, this discrete Fourier transform, the fast Fourier transform, all these are there. And they are based on all these concepts which we just saw. Right? Okay. FFT and DFT, they have difference in the complexity. FFT runs quite faster. Okay, this is the question. Now, how do we find out? How does the signal looks? First, we have two piecewise functions here, part of function. Negative 2 to 0. So, negative 2 is this, 0 is this. And 0 to 2, this is second part, second piece, 0 to 2. So, between negative 2 to 0 is negative 1. So let us go to the y-axis and negative 1. So minus 2 to 0, just make a line. This is a green line. Now 0 to 2, again it's 1. So at 1, y1, you make a line. So how does this is being made? If you increase it, you see this is a black line on these two sides. So this is the piecewise, and as I said, this is period. So this period will replicate itself. That is why it is periodic. This is the second part. If you increase the period. Now, as I told you, this fx is an odd function. You saw that is the odd function. If I turn it to 180 degree, it will be odd. So a0 and an will not be there. Only these two terms, forget it. Only bn we have to compute. Bn is what? This is 1 by p, negative p to p, fx sine n pi x by p. So this p you will see in various discussions, capital L also. Same thing. See, this is negative p to p. If I take from minus pi to pi, p is pi because the range is 2 pi. L is 2 pi. So that is, you have to take it because it is from negative 2 to 0 and 0 to 2. Actually, we are taking it from negative 2 to 2. So the p is 2 here. So fx is, let me write fx. I'm not writing full sine, just sine dx. Sine is having n pi x by 2 inside. Now, I'm just trying to show you that this is an even function. So just take 2 outside, 0 to 2, and fx, and again sine, I'm not writing inside, sine dx. Now, what I'm trying to do here is, fx in between 0 to 2 is what? See, 1. In the question it is given. So 0 to 2, this goes, fx is already 1. The sine, now I'm writing full, n pi x by 2 dx. Sine you can do it. I hope that you know this a cos term will come, then inside n pi x you will do, and then you will apply the limit 0 and 2. So the final what you get is, I have written here 2 by n pi, 1 minus cos n pi. But I told you cos n pi is negative 1 to the power n. If you remember, this is negative 1 to the power n. This whole term is bn. Now go to the Fourier series and put it, because the term is fx equals a0 term you are not going to take, an term you are not going to take. You are going to take sigma n from 1 to infinity, bn in place of bn you will write directly this term, and then sine n pi x by p. Now you see negative 1 to the power n, 1 minus negative 1 to the power n, I am putting n equals 1. What do you get? 1 minus of minus 1, that is 2 you will get. So if I put an odd power of n, I'll get 2. But if I put an even power, just put say 2. Or say, I'm writing an even number. So 1 minus of 2, that is going to be 1 minus, this is 1 minus 1 is 0. So if I put odd, all terms will be 0. So it makes more easy. All the even terms you are not going to take. You will only see the odd term here. Even there is no term. So I'm just putting it here, 4 by pi. So I'm writing the n equals 1. So you get 2 by, I'm writing in the actual term n equal 1. 2 by pi, 2 sine, and of course this 1 minus of minus 1 to the power 1 n is 2. This sine n is 1. So you get sine pi x by 2. So 4 by pi sine pi x by 2. This is n equals 1. Now you can also write n equals 3, then n equals 5, n equals 7 like this. 2, 4 will not come. I hope you got the idea. This is how we compute. There is one more explanation which I want to give here, is when you take n equals 1, one term, n equals 1 and 3, two terms. Likewise, if you take say 4, 10, 20, 30, 40 terms, then you see that this particular expression has given you the same figure, same geometric figure which we started from. Remember, this is negative 2 to 0, it was a term negative 1, and same 0 to 2 it was 1. So actual value came.